I bought half a dozen of these Russian Nixie tubes about a year ago, I guess with the intention of making a clock, though I didn't do anything with them until recently when Dave Jones on his EEVblog started describing a Nixie tube project, and he went to some trouble to work out a good way of driving them, so thanks to Dave for sussing that out, and yeah, I've decided to go with that. So he's inspired me to get this project going again. So what I did, I've got a few differences to what he did though. Instead of using pins to plug them onto a main board, I've given them each their own little circuit board, like these. So if one blows, it's not hard to replace a circuit board, and it's easy to swap them around if there's troubles. Now, unlike Dave's tubes, which are IN-12Bs, I think, these are IN-12As, and they don't have a decimal point, which is why I've put on these extra neon tubes, neon bulbs. So with one of them on, they form a decimal point, and if they're both on, then they're a colon for a clock. And even the leftmost one in a clock, for instance, might be also used to show AM or PM. And then they plug onto, this is all homemade circuit boards of course, so there's all the TPIC 6B595 chips on a homemade circuit board, and they just plug in. Now I'll show all this running in a minute, but it's not without its issues, which is probably mostly due to the fact that it's a homemade circuit board and things are a bit tight. But the three on the right hand side work, and the three on the left talk shit at me. But and I've gone in here and looked at it carefully and found a bad joint or a suspect joint or a short circuit and fixed it, and even swapped chips, and every time I do that, yeah, the fault doesn't go away, or rather I have a different fault, so there's something definitely sus about the last three digits in this thing. Now, one of the other differences from Dave's project is, I'm not sure if it matters, but he's shifting data into the shift registers from the left and I'm shifting it in from the right. It just seemed more sensible to me that way, that you start off at the unit's end and shift in more data if you've got more digits. Probably doesn't really matter at all. But now, as I mentioned, these three work properly. These three are stupid, and I've given up trying to make this thing work. What I'm going to do is get proper circuit boards made with solder mask and all the rest of it, so that hopefully the fault, whatever it is, will be gone. And further to that, I'm not going to make one big board like this, but I'm going to make it 2 digits long. So 3 circuit boards, or 4 if I put more digits on. And the reason for that is, well, it's modular and I can isolate problems as well, but with these things you've got 10 digits, which is 10 cathodes, plus the 2 neons, which are individually drivable. So that's 12 bits per display position. 24 bits for 2, fits nicely into 3 shift registers. So that's a nice point to chop it off at. So 2 tubes, 3 shift registers on these boards, and I'll just plug together. There's the high voltage power supply and a little Arduino, what makes it run. Now I'm doing this outside because this is such a shitty camera. I'm not sure what this is going to look like, but it's definitely worse inside, so I'm going to try and film it somehow inside. It won't be very good, but we'll see how it goes, and I'll show you the fault. Now we're running it. The speed gradually increases, or doubles every 2 seconds until it reaches maximum speed and then starts decreasing again. So we can see that it can bear hammer. Now these three are counting properly. You watch when it gets to that one, things don't work properly. It's talking rubbish. And now we're doing a test where we do the same digit on all 6 displays, and you can see these 3 are correct, those 3 are wrong. I guess I haven't fully considered the possibility that it could be a software issue, but I don't think so. They'll check that. In any case, I'm still going to go ahead with building separate little modules that can plug together for two displays each. I haven't got the neons running because they fire at such a low voltage, probably 80 or 90 volts, so that even the 50 volt Zenas in the shift register chips pull them low enough to turn them on when the shift register is not driven low by the MOSFET. Just the Zena pulls it low enough. So what I have to do is stick in a 50 volt Zena on the positive side of those things, 56 volt Zena on the positive side of those, so that they're only on when the driver pulls them right down to 0, and sitting at 50 volts because of the Zena on the chips won't turn them on. Yeah, so we don't see the neon bulbs at the moment. Anyway, that's it. That's enough of this. That's what it looks like, and I'll make another video once I've made the proper modules.